5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Light sails, that is really thin sails that are propelled by photons flying around in space, have been proposed as an alternative propulsion method to travel the cosmos for a long time. Now there's a startup company in France working to commercialize them. Their co-founder and CEO, Andrew Nutter, is our guest this week. Enjoy.
My name is Raphael Rodkin, and I'm an investor and advisor to space companies. Just as a reminder, this podcast is for informational purposes only, and nothing should be taken as investment advice. This podcast is sponsored by Nano Avionics, a satellite manufacturer and mission integrator. Their technologies enable many space companies worldwide to offer services that improve life right here on Earth, such as providing global connectivity, conducting Earth observation, or contributing to scientific discoveries. Check them out, and also check out my episode with the CEO and co-founder. Sadly, I am not a rocket scientist, but I'm an alumnus of the International Space University. ISU offers a number of educational programs about space worldwide. Check them out at isunet.edu.
And just some final things before we start the episode about ourselves. If you enjoy the podcast, please leave us a 5-star rating on your favorite podcast platforms such as Apple or Spotify. If you want us help expand our work, you can do so and support us at www.patreon.com/Space Business Podcast, and we'll also put that link in the episode notes. And lastly, you can follow us on Twitter at podcast_space.
Hey space enthusiasts, it's time for another episode with another European space startup. I'm very happy today to have Andrew Nutter. He's a co-founder and the CEO of Gama Space. Welcome, Andrew.
Thank you. Delighted to be here.
Great. And so why don't we start off as we always start up with startups, and could you just give us the short elevator pitch on what Gama Space is doing, please?
Gama is building solar sails to provide free and continuous space propulsion using sunlight. The existing propulsion systems today are all constrained by the need to carry fuel. And once your fuel tank is empty, that's it. You can't influence your trajectory anymore. And solar sailing changes that paradigm. This fuel constraint that has existed since the beginning of space travel disappears. So with a sail, you can accelerate through space as long as there's enough light. And broadly, that allows you to go far, it allows you to go fast, or even maintain a position in an unstable orbit. And that opens up all sorts of new possibilities for affordable space transport.
Okay, so we've got to go back and ask another question we typically ask. I mean, this is sort of like, solar sails, and we talk obviously much more in detail about the tech and what it exactly looks like. But it's sort of at the moment, correct me if I'm wrong, I would consider it a niche product. How did you guys come up with this? Is it sort of like you're sailing on the oceans and you're like, oh, I like space and let's do solar sails? Or what's the origin story there?
The origin story actually goes back a long, long way. So Galileo and Kepler were writing about sailing through space on the solar winds. And we're not actually using the solar winds, we're using photonic radius of pressure. And people have been working on this concept for a long time. It's been demonstrated in space. And now if you're sending any probe into space, you need to take it into account because it can affect the trajectory. The dream has always been, well, can we build large enough sails to go very far and very fast? And so this is always, we're driven by that dream, but the origin story for us is around, okay, well, now that we've quote unquote conquered space very close to Earth, now we need to go further out, and propulsion systems today are limited. So what do we need to build the infrastructure and that future space economy? And solar sails, I think, is a question of timing. A lot of the things that we're using today were not available until very recently. So it's more about timing and seizing that opportunity today.
Okay, so you mentioned part of the history there, and it's sort of kind of almost romantic, right? It's like sailing. It harkens back to the olden days of great sail ships. Why hasn't it, like you said, the concept is quite old and known. Why hasn't it been used before? Because, for example, you mentioned, it's good to go long distances, and we shall talk about that more detail. But, if we think about some of the objects we've sent very far, and I hope I'm not saying anything wrong here, and you correct me, I think the Voyager probes, for example, they're running basically on RTGs, on radioisotopic thermal generators. Why haven't we used solar sails so far?
It's a good question. Everything we've sent out to space gets most of its energy very early on. So it's the chemical propulsion at the beginning that throws things very far. The Voyager probes are just coasting. They're not changing their trajectory. The RTG is just providing power to keep things alive and be able to communicate. But they can't say, okay, we're going to change direction and go somewhere else. They've run out of fuel. They don't have any more propulsion. The reason why it hasn't been done is because the technology was not available until recently. And one of the properties, and I think we'll come to it in terms of the technology, is that we're using very, very thin films that are quite difficult to manipulate. And you can't really test them on Earth, because on Earth you've got air, you need a huge amount of space, and you've got other forces acting on it. So you can only test it in space. And until recently, getting to space was very expensive. And thanks to SpaceX, we can now get to space for cheap, relatively cheap, and test things and demonstrate it's a means of propulsion that can work. So I think it's a timing issue. We're lucky to be able to do it now. And other people have been working on it, and there have been other missions in the past. But we want to be the first ones to really demonstrate propulsion going from point A to point B using only the solar radiative pressure.
Mm-hmm. So just kind of to finish up on the history, because I think it's interesting. I mean, it sounds as a summary that it's sort of like we can do it now because the material science has advanced, but we can talk about that in more detail. But, we had this, so leaving aside Galileo and sort of the really old concepts, it feels like we had this, obviously golden age of space, or the first golden age of space. Yes. I hope it's not going to be the only one. Like in the 60s, where I think just a ton of stuff has been tried, right? Even if it was arguably to some extent ahead of its time. Have we tried like solar sails? Have the space agencies, like whether it's the Soviets or the Americans, have we tried stuff like that like a few decades ago?
Yeah, so we've tried a number of different things, and I think solar sails really got popularized in the 60s and 70s, as Arthur C. Clarke, Carl Sagan went on television, and he was a very famous guy in the US, and popularized the idea of sailing on light. So the Soviets worked on missions, the NASA, JAXA, the Japanese Space Agency, and some of those have actually put sails into space. So the Japanese Space Agency put a fairly large sail called on a mission to Venus, and it was a demonstrator, so they tested a number of things using a fairly large sail. NASA's got a number of missions underway, and they tested something called nanosail, which was a very small one, just to demonstrate you could deploy something and in space and kind of orient it. I think the ones that kind of captured the most imagination and up until today probably demonstrated the most is the Planetary Society, a not-for-profit group of enthusiasts who managed to put a solar sail into space on a CubeSat, so very small, very cheap satellites, and deploying a fairly large sail to demonstrate that there is an effect from solar radiative pressure on a large surface in space, a large reflective surface in space. So we're not the first by any stretch of the imagination. There's a community of people working on this in different agencies. There's many researchers doing their PhDs on solar sail navigation, and a number of scientists saying, okay, well, once we unlock this new technology, what can we do from a science perspective? So there's a huge pull from the scientific community to actually be able to prove that it works and make it work.
That's interesting. Actually, I was going to ask you about Planetary Society, because I think they crowdfunded that, right?
Correct. Yeah, they raised a few million, crowdfunding it. There were some pretty famous people who got involved, notably Carl Sagan at the beginning, Lou Friedman and others. And they crowdfunded a mission to space. And that's really a timing thing. This was quite recently, because they could get to space for cheap using, get to space for cheap on a small spacecraft. So a CubeSat. We're not talking about hundreds of kilos anymore. We're talking a few kilos, and a very simple concept to show that it can work. And you can deploy a very large surface from a very small spacecraft.
Okay, and just on a Planetary Society mission, like, because that was a few years, I think it was just a few years ago. Like I said, it was very recent. Like, is there any like conclusion yet about sort of the what were the missions? Were the mission objectives fulfilled? Was there any like interesting, experiences we've learned from this?
Yeah, so it completely demonstrated that you can deploy a very thin, very large surface from a small spacecraft. It demonstrated that there is an effect of the sun and it pushes on the sail. And they had a fairly simple steering law when it's in orbit around the Earth. I guess what's missing today, because there was one constraint, which was they had to deploy at an altitude that's still quite low. So most of the things we put into space are below 1,000 kilometers. And below 1,000 kilometers, there is still a remnant of atmosphere. And so that atmosphere will act on a very thin, very large surface and create drag.
Right.
So you're always losing altitude because of the drag. So it's quite hard to kind of distinguish between what is pushing you from the solar radiative pressure versus what's the drag. And so our next mission, I think we'll come to this, is really demonstrating the full performance of a solar sail outside of the Earth's atmosphere.
Yeah, we'll definitely come to that. But sort of let's segue a little bit into the tech there, because that's super interesting. And I must admit, I don't know too much about it yet. But for example, you mentioned sort of like it was demonstrated by the Planetary Society mission that you can unfold something. So how would one imagine that? Is that literally sort of like similar to like, folding up a parachute in a sort of very neat way, so to make sure it unfolds correctly again? And then is that something that happens sort of, for example, on its own, or do you need like any sort of like very sophisticated assisted deployment system to make that happen?
Yeah. So the material, first of all, is basically a very large mirror. And it's a very thin reflective film that will reflect the photons from the sun to push the spacecraft. The film that we're using at the moment on our first mission is 2.5 microns thick. So this is much thinner than a human hair. And the reason we need to do that is because we get more performance if we have something that's very light and very large. At the same time, if it's thin, it means you can package more into small space. And so the folding, I've learned a lot about folding over the last few years. And there's different methods. And some methods have certain advantages, but ultimately you're looking at your packing efficiency. So how much can you put into a given space? And that will determine basically how large a sail can you put into space from a given spacecraft. So it's basically folds like a I don't know if you can visualize a millefeuille, like the French cake, where you kind of you put layers one on top of the other, and you keep on folding back towards the center, and you just layer it up and up and up, and then you squash it down. That's the very simple version.
Yeah, I can imagine the French dessert you're talking about, but I don't know where all of our listeners can. So let's maybe try to quantify a little bit. So like, let's say we have like a 3U CubeSat or something. I don't know what you guys are using. You can tell us in a second.
Using a 6U CubeSat.
Okay, let's take the 6U. So the 6U with your current folding efficiency, so to say, how large a sail does that result in?
So our 6U spacecraft, which is basically the size of a large toaster, will deploy 73 square meters of sail. 73 square meters of sail is larger than the average Parisian apartments. So it's quite a large surface in a very small package. And between our first mission and our second mission, we've actually managed to increase our efficiency. So we can deploy that surface from an even smaller volume of space. So I think we've increased by order of 14 times relative to where we were at the beginning.
Interesting. And I think, by the way, the size comparison you mentioned says something both about your sail and Parisian apartments, but let's leave that aside.
Yes, completely.
I'm wondering, so you mentioned like this is obviously just a fraction of the width of a human hair. So I'm just thinking like space and, especially ultimately when you go outside, like if you go into deep space, right, as we will talk about your next missions, right? God, I'm thinking like micrometeorites, really harsh radiation, like how much is the material affected by that? And sort of like, what do you think is the duration of something like this?
Yeah, it's a good question. I think ultimately, that there's going to be a gradual deterioration in the performance. So the main thing we're interested in is the structural rigidity of the whole system and the reflectivity of the sail. The structural integrity is basically reinforced by other things. So, for example, at the moment we're integrating Kevlar wire throughout the sail, so that will not break. But what we might have is little holes from micrometeorites piercing the sail, and the sail's so thin that micrometeorite will just make a hole and continue on its journey. It's not going to hit something hard where there'll be an explosion or something you can imagine otherwise. So over time, we'll have a few holes in the sail material, but the structure won't change. And the reflectivity over time, in terms of efficiency, will probably go down gradually over time. So we take that into account with the models we have. We could theoretically sail for a very, very long time, hundreds of years, because we don't carry any propellants, but the material of the sail will deteriorate over time and will lose efficiency.
And so if we move on to maybe some of the other specs, so we talked about size. Oh, by the way, I should ask, again, how much does something like this then weigh? Is this like a few kilograms, or how should one imagine this?
The sail itself is in the order of a few hundred grams, so incredibly light. The heavy stuff is all the rest, the satellite bus, the components within that. But the sail itself is incredibly cheap. And that's what's interesting. If you can put a bigger sail, it doesn't add that much mass.
But ultimately, I guess you have the satellite bus, but there's some things that would be on a regular satellite bus that you don't need, right? So it's really the payload plus some supercritical subsystems, I guess.
Exactly. And we could, there's things that we need. So I don't know how technical we need to get, but there's things like reaction wheels that can apply torque to this satellite. So we can actually change where the sail is pointing so we can control our destination. Those things need to be there because we depend on them, and they're quite heavy. So there's still a number of things that are heavy, and over time, as technology improves, we can find alternatives to that. But currently, we rely on existing off-the-shelf components that are quite heavy.
Yeah, and I guess there'll obviously be some primary payload because you want to do something, right? Like a sensor to observe something, right? And then you want to get that data back, so there's going to be some sort of, I guess, radio, right? And then there's going to be something to, like we said with Voyager, to power the radio.
Yes. Okay. Yeah. So we'll have solar panels that are off the shelf today. The Japanese mission Icarus actually integrated panels into the sail material, so very thin solar panels. So we can do propulsion plus power from a single subsystem.
Oh, okay. Interesting. Because my next question is going to be, is that like solar panels, I'm picturing this like big arrays, right? And I don't know precisely now how heavy they are. I would have thought, is it not better to have sort of like something that has really high energy density, like a radioisotope generator again?
Yeah. I mean, we're also about reducing the cost of access, and the radioisotope generator is expensive. Solar cells are off the shelf. We can use them. We can buy, there's a catalog. You can pick the one you want. And we don't actually need a lot of power. Because we're using, power typically is for electric propulsion, and it's quite an energy intense form of propulsion. The solar cell doesn't need that. So we're just using power to maintain communication links, to power the batteries, to do a few kind of things on the system, which doesn't actually need a lot of power.
Understood. And so if we move on to some of the other sort of interesting specs, so let's talk a little bit about velocity and acceleration. And I don't want to turn this into like a physics podcast at all, but I guess sort of like on the most basic level, like, famous Newton formula, F, force equals mass times acceleration. And then sort of your mass is like, we just went through your mass. It's quite low, which is great, right? The force, I also imagine, is actually really, really, really tiny, but it seems like something it's always there. So does that mean you can you just could keep accelerating forever?
Yes. The short answer is yes. And maybe we take a tiny step back just for your listeners to understand what's happening. So we're putting up a huge mirror in space, a very, very thin, very large mirror. And a photon has no mass, but it has momentum. So when you reflect a photon, it will transfer some of that momentum. So it's a little bit like you're playing billiards and you hit the white ball and it bounces, it transfers some of that momentum onto the thing that it bounces against. And that's really how the energy is transferred and what we're using. And so indeed, the force of an individual photon is incredibly small, and on force, on Earth, you don't notice it because there's other forces that are much greater. But in space, if you have a large enough area, those photons can create enough force to accelerate a spacecraft. And as you rightly said, in space, there is no friction, there is no drag. So that acceleration can continue to accumulate over time. And we're talking in the millimeters per second squared in terms of accelerations. And, over a few minutes, that doesn't do much, but over a day, over a week, over a month, that can really accumulate. And the really interesting thing is that the mechanics, to simplify it, are two things. One is you double the size of the sail relative to the mass. You double the force and you double the acceleration. And the second thing is, if you get closer to the sun, you're actually getting into a much more dense flow of photons. And therefore, if you can go closer to the sun, you can pick up tremendous speeds because there's just much more energy for you to capture and harvest. So ultimately, you can go incredibly fast. And if you're even thinking a little bit further out, Breakthrough Initiatives, for example, is a group of people working on trying to send miniature sun sails, light sails, to Alpha Centauri. So 20 light years, 20 years of transport going at 20% the speed of light. And these are tiny sails accelerated by artificial light. So giant lasers accelerating tiny sails to go to 20% the speed of light. So that is an objective that the community is interested in, because finally we can leave our solar system and go and explore further out. But in the short term, we're working with very small forces. We don't have giant lasers, and we're not diving very close to the sun. So we can accelerate constantly over time, keep on accelerating, and go to places we couldn't go before, but the speeds are not yet close to a percentage of the speed of light.
Yeah, we'll come back to, I think, both Project Breakthrough Starshot, and sort of like what other missions you can do in a second. You kind of mentioned sort of like being closer to the sun, accelerating, and forgive me, I just cannot help opening a bracket here. And you may have seen there was a previous podcast here with Professor Avi Loeb from Harvard, and of course we had Oumuamua, the extrasolar object coming through the solar system, and Professor Loeb sort of maintains it is a possibility that, or one of the potential explanations is because what we saw is Oumuamua accelerated basically when it passed the sun, which you couldn't really explain very well. This is a very long discussion. I don't know. Is this something you guys have discussed internally?
Yeah, we've definitely discussed, and we even had a film crew come and spend a bit of time with us because they're doing a documentary on that topic. And so, is Oumuamua a giant light sail sent by an alien civilization? Maybe it is. It's interesting, and we should definitely investigate. So it's something, these are the things we talk about at lunch break and when we're having a coffee.
Happy hour.
Because they are absolutely fascinating topics. So if you had an intelligent civilization a long way away, they'd probably reach the same conclusion as us and say, well, you can accelerate something to pretty high speeds by using light, so an abundant resource that we have on our doorstep. And so if we've thought about it, then it's likely someone else has thought about it and maybe actually doing it.
Yeah, it's almost like, if I put on my venture capitalist hat, it's like the ultimate like startup use case validation. Like aliens who are probably much smarter than us have come up with this. But anyway, let's close this bracket here and sort of, okay, if we don't use giant cool lasers, as is proposed by Project Breakthrough Starshot, and by the way, as a note to listeners, not only was Professor Avi Loeb on this podcast in the previous episodes, if you want to listen to more about Oumuamua, you can do that. Also, Dr. Pete Worden, who is leading Project Breakthrough Starshot, was on the previous episode of this podcast. But if we leave aside the use of giant cool lasers and sort of just use the existing available photons, so to say, where do you see some of the sort of sweet spot use cases? Like, for example, would it make sense to use this to go to Mars, or is that just too close? Is it more like, you want to go to like the outer solar system or even outside the solar system?
Yeah, so I think the features that we have with the solar sail is you can go further, you can go faster after some time, but also that you can stay in one place. You can do station keeping. So a little bit like a helicopter hovering over certain points, you can do that because it requires constant acceleration. And the last feature is you can do things for a fraction of the cost because you're reducing your system requirements and you're reducing your need for fuel. So you tell that to scientists, to agencies, to companies and entrepreneurs, and it's like you're giving a new tool that's unlocking the next level of a game. So all these things you can do or even imagine before, now you can start conceiving. And I should also make just a quick comment. There's some things you can't do with the solar cell. So you can't carry humans, for example. People need a lot of stuff to keep them alive, and that takes up a lot of space and it's very heavy. So that's not suitable for humans. But here we have a platform, and now we need to think about what are the applications for that platform. And that's where it gets super exciting, and that's where we talk about asteroids, solar storms, or even leaving our solar system. So I think when you think about applications and the business case, you need a good mental model to consider them. And I think that breaks into two components. One is you need to think about alternative forms of propulsion and navigation in terms of performance, in terms of cost, in terms of complexity and reliability. Are you better than other solutions for a given objective? And second, you need to think about timelines and markets. So when are the various transportation needs going to materialize? What's their value? And can your technology be mature enough and cost effective to meet those needs at that time? So on the first point, relative to other technologies, I don't think it's going to replace electric or chemical propulsion, but what it does do is expand the possibilities. So as an example, on Earth, the Ariane 6 rocket will be transported to Guyana on a boat that's using sails to reduce consumption by something like 40% and pick up speed. So can you combine a solar cell with other technologies? But the really big paradigm shift is when you look at the cost dimension. And Gama will provide high performance, reliable system to reduce the cost to get further out. So what are the markets? What are the applications? We're looking at a number of different things. If you look long term, so you can look at leaving the solar system, dive by the sun, you harvest a lot of momentum from the dense flow of photons, and you go far out. And that, from a scientific perspective, is phenomenal. And you can do all sorts of things. You can go to very far out. You can turn back. You can look at light from a distant planet, and that light is going to be warped by the sun's gravitational field. So you have basically, you're using the sun as a giant telescope to see things very far away. So this is something that will get a scientist super excited. In the medium term, you can do things like solar weather monitoring. So if you can imagine a line between the sun and our planet, there's a point in between where you're pulled equally between the sun and our planet from a gravitational perspective. With a solar cell, you can go beyond that point and you can stay on that sun-Earth line. And why that's interesting is because every once in a while, the sun has some activity and you have what's called a geomagnetic storm that races towards the Earth and can do a lot of damage in space and on Earth. So a really interesting application in the medium term is putting a fairly large solar sail beyond that point of equilibrium to give us an early warning system when there's a threat to Earth. In the medium term, you've also got things like space-based solar power. So can you put very large deployable structures in space and beam down energy? So one of the components that's going to be required for that is how do you deploy these large structures in space? How do you control them? And how do you optimize for beaming energy down to Earth? But in the short term, which is where we're spending most of our time, let's take three specific use cases. One is giving additional efficiency to spacecraft in geostationary or in lunar orbits. So we're having a few discussions on that point. A second point is around deorbitation. And the reason it's interesting is if you have you can deploy a large structure in space, you can also do it quite close to the Earth to deorbit spacecraft much quicker. And this is becoming an important topic because the laws are changing. And previously you could leave stuff in space, or you could try to take them down within 25 years. But now you need to take them down within 5 years. And you don't need a very large Dragsail to be able to deorbit something very efficiently towards the end of the line.
But that wouldn't also require the Dragsail application. It doesn't sound like something that would require your sort of like super high-tech expertise of like, that's
exactly.
just like a sail, right?
It's just a sail. It's a subset of everything we need to do. We don't need to navigate with it. We just need to deploy it. And that will deal with
it requires some of your expertise, like, so for example, your packing expertise, but you don't have the super high-tech material that's super light but reflects sunlight. Okay.
Exactly. And it's also kind of all the things that we're building to build the sails. So we're building the tools to be able to industrialize this and make, if we need to make 200 deorbiting sails, we can do that with the tools that we're building. So that's also interesting for us on a very short-term basis. The mission that's probably the most exciting for us in the short term is prospecting what's known as near-Earth asteroids. So these are asteroids that are very close to Earth, I should say these are very distant objects, but very close relative to other asteroids in our solar system. And they're basically floating a little bit ahead and a little bit behind our planet. And these are asteroids that are super interesting from a scientific perspective, but also from a commercial perspective. Scientifically, because it gives us answers to the origin of life. We've just returned some samples from an asteroid called Bennu that had carbon and water within the clay of the material. So these are things that are very interesting. But from a commercial perspective, you've got all sorts of different types of asteroids. And some of them are, for example, metallic asteroids that have iron and nickel, but also contain rare earth metals like platinum, gold, iridium, palladium, and other types of things that are in concentrations several times higher than what's found on Earth. So as an aside, it's crazy to think that today we're extracting things in a very polluting way on Earth. And all these very high value things are just floating around in space, not too far away. So someone wants to harvest that. Someone's going to want to commercially exploit that. But the first thing you need to do is actually kind of create the map of where the resources are and what's actually exploitable. And a solar sail can go to one asteroid fairly efficiently, but then keep on going to visit other asteroids. So in the history of humanity, we've managed to kind of go fly by or touch 17 asteroids. And in a single mission, maybe you deploy 5 or 6 solar sails. Maybe in a single mission, each one can go and visit 2 or 3 asteroids. And then you're starting to build that map of the resources in space.
Absolutely. And asteroid mining, of course, is also something that's, it had sort of its heyday 10, 15 years ago for startups, which, as we now know, was too early, unfortunately.
Yes.
But it's now coming back. And there's companies like Astroforge, which also is on a previous episode, wanting to commercially exploit asteroids. Now, you mentioned OSIRIS-REx and Bennu. So I think, again, to kind of give us a sense of the comparison here between the propulsion methodologies. From memory, I think OSIRIS-REx, it took something like a little bit over 2 years to get there. And I think it was like a couple 100 million kilometers away. So if we did that with a sail, kind of what sort of, time would we talk about?
Well, we've got a very good data point because NASA had a mission called NeoScout that was actually launched on the Artemis mission recently, but unfortunately they didn't manage to establish the communication link with the satellites. But it was called NeoScout because it's Near Earth Asteroid Scouts. And with dimensions very similar to what we're doing, they were going to get there in 2 years. So very similar to a mission that would cost billions of euros or dollars, but for a fraction of the cost. And that's what's interesting. Obviously, the OSIRIS-REx mission is hugely ambitious and very impressive. But there's definitely a space to go and do these things for a fraction of the cost and at least do flybys with spectrometers and cameras to see what's there, what it looks like.
So leaving aside, some of the, let's call them orbital applications, like the Dragsails for deorbiting, if we're talking for these, longer in terms of, I guess, both distance and time missions, is it like all space agencies, or what does your go-to-market look like here? I guess you could even do what the Planetary Society has done. You could just come up with your own missions and try to get them financed. But how are you guys thinking about the go-to-market there?
Yeah, so there's a few options. And I think when we started, the only option to us was space agencies. And the model there is, okay, well, you want to do all this science in space because ultimately that's what you're focused on. But your budgets are limited. And so every once in a while, you can do these flagship missions, cost billions of dollars. What if we told you to do not all that science, but a fraction of that science, a percentage of that science for a very small percentage of what one of those missions would cost? Would you be interested? And so everyone said, yes, we'd be interested, but you need to prove it to us first. And so this is, in our roadmap, we first need to demonstrate that this works. It's a viable and reliable technology. And so that was our only go-to-market, the only one we could think of. But since having started, we've now been approached by larger, more established commercial companies saying, this is an interesting capability. Can we add it to what we currently have? Or can we look at some other missions in cislunar space that use solar sails? And you mentioned Planetary Society and crowdfunding. There are a lot of people who are very supportive about what we're doing, including some companies that don't do very much in space today. So our sponsor, for example, we've got a corporate sponsor on our first mission. They are called CMA CGM, and they are a company no one's really heard of, but they are one of the 3 largest maritime shipping companies in the world. They've reduced the cost of moving something from Asia to Europe to a fraction of €1 per kilo. So it's really the lifeblood of many economies depend on transport. And they're thinking, well, where are the needs moving to? And on Earth, we have certain needs, but what about in space? How do we do transport in space? How do we do logistics in space? And there are lots of ways to do it, but we are one part of that roadmap. So imagine being able to have a kind of motorway of solar sails accelerated by lasers between Earth and Mars and transporting things for a much lower cost per kilo than other forms of transport. And that's really, that's kind of opened our eyes to more commercial interests who are willing to support us to demonstrate and to prove that this is a viable transportation method. Because, who knows exactly what the needs are going to be in the future, but we know there's going to be a need for transport. We know there's going to be a need for power. We know there's going to be a number of needs to build that space economy. And we're just providing one of those elements, one of those bricks.
And so, as you mentioned, one really important element here is the demonstration. I mean, it's funny, usually when we talk to space startups, we talk about the IOD, the in-orbit demonstration, because people, that's what matters. For you guys, as we already discussed, it's actually, you should demonstrate it outside of the orbit. Mm-hmm. So when are you going to have your, what would it be, your EOD, your extra orbit, or your deep space demonstration? What's the plan for the mission there?
Yeah, so we have one satellite in orbit today, which is at 530 kilometers, so still within the Earth's orbit. We're using that as a test bed for operating a satellite, refining our GNC algorithms, and ultimately that's going to deploy and deorbit very quickly as a Dragsail because there's still atmosphere at that altitude. Our mission to above 1,000 kilometers is scheduled for 2025, and we are going to be going up on SpaceX, and then an orbital transfer vehicle is going to take us up even further to about 1,000 kilometers. And from there, we will deploy the sail and go from a point A to a point B in space using only the solar sail. And we need to make sure that it's undeniable that it's the solar sail. It needs to be measured sufficiently accurately so we can actually say, well, the performance of the solar sail was this. And this is what our customers want to see. So that's scheduled for 2025.
Okay, so that's kind of one of the most important, relatively near-term milestones you guys are embarking on. What does the rest of the timeline look like for the company? And then also, I was curious, sort of like, if everything goes well in the near term, what is your guys' like long-term vision? Like, what do you want Gama to be in 10 years time or so?
Yeah, so the The plan is, at the moment, it's a sequence of missions with increasingly ambitious objectives. So our second mission is this mission we've just talked about. The next one, we're planning to go to an asteroid, and we're planning to fly by an asteroid and take some imagery and send back some interesting information.
And would that be for a customer or on your own?
The discussions we're having at the moment, the discussions we're having at the moment is kind of parallel track between space agencies. So can we carry scientific payload that's interesting, and they would pay for that. But some of the interest is more commercial. So saying, okay, well, if we can create this pirate's map of where the treasure is in space, that's going to have a huge amount of value. And so some of our investors, some of the investors we're speaking to, and some of the commercial companies we're speaking to are interested in that dimension. So it will be financed possibly from a combination of an agency plus a commercial company and some commercially minded investors. And to get to the rest of your question, which is where do we want to be in 10 years' time? The thing that drives us the most is around going far and learning as much as we can about space. That's what motivates us. So the dream is to be able to have an industrial facility that can produce solar sails at scale at a fairly low price points, and therefore being able to have, instead of a mission sending one spacecraft to one asteroid, we can send 10 spacecraft, all the same specifications, just with different destinations, and do multiple missions with the same technology. So flotillas of solar sails racing through space and doing science and doing commercial, having commercial objectives. And then further on, then we can really dream and we can say, well, let's leave the solar system. Let's dive towards the sun, pick up tremendous speed, and build the fastest human-made object in the history of mankind.
And then it's funny, flotillas, it really would be like Back to the Future, right? Sort of like that, aged about 500 years ago, the great exploration age on the oceans on Earth.
Yes.
So again, it's very, very sort of romantic, nice notion. So in terms of your business model, so right now, are you basically selling the sails by the unit, or are you selling entire missions, or both?
At the moment, we're selling missions, but the more near-term commercial applications, we would sell a component, which would be the sail, but also the algorithms to control it. So half the team is working on the software side, and that's the algorithms to control a very thin, large sail in space.
Understood. And so as we come towards the end here, some of our questions we always ask. So first, about your local ecosystem. You guys, I've been to your facility actually,
yes,
sort of accidentally, because I was visiting our portfolio company next door, the Stellar Lab. I didn't realize you guys were neighbors, but it was nice because I could come and see your facility. How do you find the local space ecosystem in Paris?
The ecosystem is very good. So I've worked in many different countries, and I chose to come to France because there is an interesting tech ecosystem. And from an engineering perspective, they're very good engineers who are specialized in aerospace. So you have quite a wide talent pool. You also have a rich history of space. And by that, I mean there's some fairly large companies. There's a space agency, the CNES, that's been very supportive. So they give us money, they give us expertise, and they give us facilities. So I don't think, honestly, we could have done as much as we've done without their support. And on the next mission, we're collaborating with the DLR, so one of the teams at the German Space Agency. So the ecosystem has talent, it has money, and it has facilities. So I'm really bullish about the French tech ecosystem, but also the wider European ecosystem. I think we still have some things to catch up with relative to the US, but there's talent, there's people with ambition, and increasingly support from agencies to support startups and the tech ecosystem around.
Yeah, and I must say, it's also nice that not every single French space company is based in Toulouse. I mean, nothing against Toulouse, but Paris is just a very nice city. Never mind the apartment sizes we already talked about.
Yes.
So speaking of talent, are you guys currently hiring?
We are hiring a couple of people at the moment. I think we've got the team that we need to go for the next year or so. Okay. We'll be looking for a mission manager, / systems engineer who can help coordinate some of the projects we've got in the pipeline, and possibly someone quite senior who's done GNC for more distant space, so guidance, navigation, and control. We've got a steady flow of incredible people coming out of universities who've been studying solar sailing for their PhDs, and they come out and they say, okay, well, what do I do now? Where do I go? There aren't that many places to go. So we've got a very rich talent pool with some very smart people working on the topic.
That's great. And so the last couple of questions we always ask, the first one is, if you weren't doing Gama, sort of, and you're a person who obviously knows the space sector in general very well. I mean, we're both also mentors at Creative Destruction Lab Space Stream. So, I know you see and know about a lot of other space companies and what they're doing. What else do you find interesting in space right now as a business? Not specific companies, just as like themes. Yeah,
themes in space manufacturing. So super interesting. At the moment, everything we put into space, we need to build on Earth. And that doesn't necessarily make sense. If we're in space, we can start to build much bigger things and much more ambitious things that have direct implications on Earth. And, as one example, imagine a world in which we completely screw up our climate and we cannot control the temperature on Earth. One of the solutions is to put lots of little solar sails in between the sun and the Earth and reduce the amount of energy coming to Earth. But to do that, we need a lot of them. And the best way to build a lot of them is to have facilities in space that are mass producing solar sails. So many, many topics like that. And I think, how do you build things in space? How do you create an infrastructure also for humans further down the line? I think there's a lot of people, and many don't realize this, but it's not just the agencies going to the moon, going to Mars. There's a number of private companies financed privately with private customers, trying to get and build all that layer of infrastructure. So everyone is dependent on everyone else in the space ecosystem. We need the infrastructure to be built across the value chain, and we're providing one part of that on the transportation side. But there's a lot of other companies doing exciting things too.
And our traditional very last question, which is always the same, is about science fiction. And at the very beginning, you've already mentioned some science fiction authors as part of even the history of light sails. Mm-hmm. What are some of your favorite science fiction works?
Yeah, I think I have to say, space to me is almost like science fiction. I look at a photo of a nebula or famous photos like the Pillars of Creation, and that to me just sounds like science fiction. It looks like science fiction. They should be in the Louvre. They're beautiful, they're complex, there's violence, there's sheer scale in time and space. So I get quite excited when I see things like that. And I think science fiction to me has played a huge part in my early life. And most importantly, I think, was Star Trek as a young child, The Next Generation with Patrick Stewart and Jean-Luc Picard. And they are aboard a ship and they're navigating far away, discovering new things, exploring strange new worlds, seeking out life, to boldly go where no one has gone before. And that's what we want to be doing. And I think that has played a huge part in my view of space. So yeah, I think science fiction, space is science fiction, and science fiction has driven many of us to join this industry and try to go further out and explore these distant lands.
Yeah, no, great. And you, as you can imagine, you're certainly not the first person who mentioned Star Trek: The Next Generation. But listen, thanks so much for coming on. Really good luck for your next very important mission, and I hope you just keep going from there and do, for example, the asteroid sort of like prospecting missions to create that pirate map. I think you may want to, maybe you could even do like a little pirate flag on your spacecraft on your sail. It'd be very cool. But best of luck. It was a pleasure to have you here.
Raphael, thank you very much.
Well, that's it for another nominal episode of the Space Business Podcast. If you like this podcast, please consider giving it a 5-star rating on your favorite podcast platform, such as iTunes. You can follow us on Twitter at podcast_space. Also consider supporting us at www.patreon.com/spacebusinesspodcast. If the podcast got you interested in learning more about the business opportunities in the space economy, check out my new online course on space entrepreneurship on udemy.com. The link is in the episode description. Lastly, if you have any feedback, including ideas for guests, and that may include yourself if you have an exciting space story to tell, or interested in being a sponsor, drop us an email at spacebusinesspodcast@gmail.com. I look forward to seeing you for the next episode.